not pass PWM value, we now need to pass a function parameter as value. So that basically what need to happen there. So I'm going to go ahead and just copy the same line of code and pass it here right there. So now this will eliminate the need to basically repeat code. Now let's go ahead and build this. So if everything is fine, we should have no error reported, right? So the code compilation is completed and there is absolutely no error. So at this point, all we have to do now is to load our binary or hex file onto the Arduino. Great. So our Arduino file is pwm_dac_lcd. Now let's go ahead and navigate into the folder so that we can actually find our hex file and load it onto the Arduino. So pwm_dac_lcd, and we need a hex file. Let's pull it in and okay. Now at this point, all we have to do is to basically just run this, and if everything have been done correctly, there we go. We should be having the duty cycle display and the voltage, right? So as you can see, with a duty cycle of 27-30%, we've got a voltage of 3.5. Incrementing, actually it's incrementing faster, we cannot keep up, but you realize that at a duty cycle of 100 we should also have a voltage of 10 volt or so, right? So 70%, 7.4 volt, 80%, 8.1 volt, and you can see that the analog to digital converter is indeed working. So at every duty cycle incrementation, we've got an analog voltage corresponding to the specific duty cycle. So this is how you can do this and implement this onto your specific project. So thank you guys for watching, and once again, if you find this tutorial useful and helpful, please make sure you give it a thumbs up and subscribe to CMTEQ channel. Stay tuned for more tutorial of this nature. Until next time, cheers.